Hey guys, welcome back. So in the last video, we saw bubble sort. Hope you have understood that sorting algorithm. Now in this video, let's see the next sorting algorithm, that is selection sort. So what is selection sort? Selection sort is very simple algorithm. It is based on the idea of finding the minimum or the maximum element in an unsorted array and then putting it in its current position in the sorted array. Now what does that mean? Let's see using a simple example. So let's say this is the array that we want to sort using selection sort. Now what selection sort does is, it divides this array into two parts. One part will be the sorted array and the other part will be unsorted array. So right now, as we can see, this array is unsorted. So we'll say this part of the array right now, which is null, is sorted, and this part of the array is unsorted. Now what we do in selection sort is, from unsorted array we will take the minimum element and we will put it at the first location. So in this unsorted array, the minimum element is 10. So we will put it at the first position of the unsorted array. So we put 10 over here and 30 comes over here. And also we will increase the size of the sorted array. So sorted array size is now 1. So we can say this is our sorted array and this is our unsorted array. Now we again follow the same steps. That is, from this unsorted array we will take the minimum element and put it at the first cell. So the minimum element is 20. So we'll put 20 over here and 30 will come over here. And of course we will increase the size of the sorted array. So now our sorted array is having 10, 20. Unsorted is having 50, 30, 60 and 40. Now again we'll do the same thing. That is, from unsorted array we will take the minimum element. So here 30 is the minimum element. We will put it at the first cell of the unsorted array. So 30 comes here and 50 moves over there. And once again we increase the size of the sorted array. Now we'll do the same step again. Unsorted array, which is the minimum element, 40. So we need to swap it to the first element of the unsorted array. So now our sorted array is having 10, 20, 30, 40. Unsorted is having 60 and 50. Again we'll do the same thing. Which is the minimum element in this unsorted array? 50. We will swap it with the first element. Now our sorted array is 10, 20, 30, 40, 50. Unsorted is 60. Now since this is the only element in this unsorted array, there is nothing more to do a sort. So we'll leave it as it is. So this is our final answer. That is 10, 20, 30, 40, 50 and 60. So to summarize the entire algorithm, what we have done? We have taken this array, divided it into two parts, sorted array, unsorted array. Initially sorted array was null and unsorted array was the entire array. Then in unsorted array, in every iteration we go and find the smallest element and swap it with the first cell of the unsorted array. Once that is done, we increase the size of the sorted array and we repeat the same thing again for unsorted array. Fine. Now let's see the selection sorts algorithm. So A is basically the array which we want to sort. Here we have an outer loop which basically runs from first to the last cell of the array. Then here we have a minimum variable which basically stores the minimum amount or the value in the unsorted array. This loop basically travels through entire unsorted array. Here we do a comparison, that is, if we find a minimum, we keep it in the minimum variable. And finally, we do a swap. Fine. So I hope you have understood the algorithm. Now let's see the time and space complexity of this algorithm. So this loop will run from first till the last cell of the array. So it will take order of n time. Similarly, here we have the loop which will run for order n time. Rest of the actions are all constant time operations. So if you add all of them, it becomes order of n. Now since both of this loop are nested, so we have to multiply both of them. So it comes to order n square. So time complexity is order n square. Space complexity is order of 1 because we are not using any extra space for doing this sorting method. Fine, so that is all about the selection sort. Now let's quickly see that in which scenario should we use selection sort and in which scenario we should avoid it. So we can use selection sort when we don't have any additional memory because selection sort does not require any extra memory, so in those cases we can use it. Also, when we want a simple or a easy implementation, selection sort is the one to go for. However, as we have seen, selection sort creates a little problem with the time complexity. It takes order of n square time, which is way more than order n log n, which we are going to see in the future videos. So in case if you are little concerned about the time complexity, in those cases we should not use selection sort. Fine, so that is all about the selection sort. Now in the next video, let's see the next sorting algorithm.